Hello everyone, I am Vivanchala. Welcome to my YouTube channel, Space Engine. This is a series of short videos in which I will explain some concepts about the universe. As such, theory of general relativity, dark matter, and particle physics. I will upload every day, so stay tuned. I hope you enjoy. Today's topic is energy and matter. Earlier in the 20th century, Albert Einstein made a profound realization that mass and energy were equivalent. They related by his iconic equation, E equals mc squared. C is a huge number, and this means that a tiny amount of mass is equivalent to a phenomenal amount of energy. The sun and all stars like it in the universe are liberating just under a percentage of their mass into radiant energy, and this sustains a lot of life on Earth. Mass energy is the most efficient energy source imaginable, billions of times more efficient than energy from rearranging electrons in chemical bonds. And you can see why people put a lot of effort in trying to generate fusion energy as a routine and reliable energy source. It turns out that it's so difficult that fusion has only been harnessed for tiny fractions of a second, and not really in a sustainable way. But it is needed as the dominant force in the universe is gravity. Even though it's the weakest of the four forces of nature, its infinite range and universal positive attraction means that it governs how structure happens in the universe. The theory of gravity first came to us from a genius of physics and astronomy of the 17th century, Isaac Newton. Isaac Newton was an extraordinary figure in the history of science. Early in his life, he came up with a theory of gravity that has stood us in a good stead for centuries until it got its final adjustment in general relativity from Albert Einstein. Even though Einstein embellished the theory with a theory that acts better in situations of strong gravity, Newtonian gravity still works perfectly well, and it's precise for most situations in the solar system and the galaxy. Newton's universal law of gravitation states that the force between any two isolated objects is governed by the mass and the product of the mass between the two objects and the inverse square of the distance between them. In general relativity, our best theory of gravity, space and time are related, and they occur by the existence of mass and energy. This is a quite different concept from Newton's theory of gravity, where space and time are distinct, and mass and energy are distinct. In Newtonian gravity, space is infinite and linear, and time also. In Einstein's theory of general relativity, they are coupled and they can be distorted by the presence of matter or objects. The predictions of general relativity started with a slight deflection of starlight caused by the curvature of space-time near the sun. That was confirming this theory within a year of it being published. Since then, this phenomenon of gravitational lensing has been observed thousands of times. Another prediction of relativity is that time is slowed down by stronger gravity fields, and this has also been observed many times. The strongest exposition of general relativity occurs when gravity is intense, such as collapsed objects like neutron stars and black holes. But even the subtle distortions of space and time can be observed in the perimeter of the Earth and its observations. For example, the GPS satellite network incorporates general relativity to give correct distance measurements on the Earth. Thanks for watching. Please share your thoughts and ideas in the comment section below. Bye.